Hello everyone, in this video I am going to discuss about power system protection module 1. First we will see the syllabus content of module 1. So module 1 consisting of 3 parts. First one is introduction to power system protection. So in that you are going to learn about need for protective schemes, nature and causes of faults, types of faults, effects of faults, fault statistics, zones of protection, primary and backup protection, essential qualities of protection, performance of protective relays, classification of protective relays, automatic reclosing, current transformers for protection, voltage transformers for protection. And second part is relay construction and operating principles. So it consists of introduction, electromechanical relays, static relays, merits and demerits of static relays, numerical relays, comparison between electromechanical relays and numerical relays. And last part is overcurrent protection. So in this you are going to learn about overcurrent protection introduction, time current characteristics, current setting and time setting. So this is the syllabus content of power system protection module 1. So we will see the one by one. The first one is need for protective schemes. Why it is required? Protective schemes, why it is required for power system. Every power system consists of mainly 4 parts. One is generators, transformers, transmission lines and distribution lines. So these are the major parts in power system. Whenever short circuit occurs due to abnormal conditions, so due to lightning or due to short circuit, sometimes short circuit occurs. So in this case, the heavy current will flows through the system. So causes the entire equipment. Suppose if you take a generator, so heavy current flows, so entire equipment will damage. To avoid that one, so that means, so to avoid heavy current flows through the equipment and damaging the equipment, so we require power system protective schemes. So next one, whenever fault occurs in an element of power system, suppose due to short circuit fault or overcurrent fault occurs, so we cannot go and we cannot remove, fuse or isolate the fault at every time. So in place of fuse and in place of isolators, so we are using the automatic protective devices. So why it is required? Why you are using automatic protective devices? So these devices are automatically isolate the faulty part or faulty element quickly. The fast of operation of the automatic protective devices are faster than manual operations. So automatically it will isolate the faulty element and it will protect the healthy section of the power system. So in normal operations, so we require power system protective schemes. So and also along with generators, transformers, transmission and distribution lines, we will have other parts also like current transformer, voltage transformer, those devices. So here what type of protective devices we are using? So here protective system or protective schemes consisting of small ratings. So we will use the fuse, and suppose it is more than 440 kVA, 440 kVA. So we will go for HRC fuse, and sometimes we will use MCBs, circuit breakers, transducers like current transformers, voltage transformers. Current transformer, what it will do? It will sense the high current. Voltage transformer, what it will do? It will sense the high voltages. And also protective relays. So these are the devices we are using isolate the faulty section of the power system from healthy sections. So generally in heavy voltage or heavy high rating applications, so we will use circuit breakers. Further modules, you are going to study about different types of circuit breakers and different types of relays, right? So next one, we will see the nature and causes of faults. So why is fault occurs? So faults are called either by insulation failure or by conducting path failure. Suppose insulation fails. So insulation fails or conducting path fails. So generally faults will occur. The fault means failure. Fault means failure. The failure of insulation results. So suppose insulation fails. So it may goes to short circuit, and also heavy current flows through that system. So it will harmful to the equipment. So further the equipment will damage. So every time equipment is damaging, every time if you replacing, the cost will increase. So we cannot invest at every time. So due to that, so we are using the protective devices. So where the faults majorly occurs, the most of faults on transmission and distribution lines are causes. So by over voltages due to lightning or switching surges, or by external conducting objects falling on overhead lines. So maximum of the faults, if you take entire power system, so generally generators will not damage, transformers will not damage, mainly high faults will occurs in the transmission and distribution lines. Suppose example, due to rainy seasons, wind is more, then sometimes trees fall on the lines, so then lines will broken and lines will damage, then faults will occur. It may be line to ground or line to line faults also. Sometimes you can observe on the transmission lines, boards also sometimes it may play. So two boards are sitting on the two different lines, and those boards are playing each other. So it is also causes faults on overhead lines. So these are the nature and causes of faults. So to avoid these faults, we need to use protective devices, right? So next, coming to the types of faults, there are two types of faults. So these two are major faults. One is symmetrical faults, another one is unsymmetrical faults. So symmetrical faults means three-phase fault is called symmetrical faults. Unsymmetrical faults means single phase to ground, that is LG fault, and another one is two line to ground, that is 2LG fault, and phase to phase fault, LL fault, and open circuited phases winding faults. So these are the main faults. and sometimes um, simultaneous faults. So these faults are very rare. So majorly these two types of faults are occurs in power system, right?